All right, Chemistry 11 students. This is another one of our online YouTube problem solving sessions. The sheet we're going to be working with today is obviously the formula determination worksheet number 2. It might have been molar chemistry and formula determination worksheet number 2. It's on your D2L site for the class, and I'm going to go over select problems today. I can't go over all of them. The video would just be insanely long. But I'm going to take certain ones and I'm going to do a few from that back section. The last few, I said there's an extra little hitch to those problems. I let you guys try to maybe solve it yourself, see if you could figure out what was going on there. Today we're going to look at what that extra little hitch is. It's a very simple extra little step that those ones required in order to be solved. So without any further ado, let's get into the problems. Now, if you remember from last day, there were steps to determining a formula, right? Actually, first, let's go over the tools. I need my periodic table right now because it has the average atomic mass for all the elements that we're going to be using. When we are converting grams to moles or vice versa, I need the molar mass. The molar mass uses the atomic mass for the elements involved in the compound. I also need the Calculator-O-Matic 3000 solar powered edition. So when the zombies come attacking, we can still do our chemistry homework, even if they knock the power out. Anyway, I'll put my trusty Calculator-O-Matic 3000 off to the side. We'll use that as it is needed. So I should have those things out if I'm going to be doing some problem solving. So the first question that I want to do, now, I'm going to skip over the molar chemistry stuff, the how many molecules would this be, how many moles would this be. I mean, if you have a problem with those, definitely by all means reach out to me and I'll walk you through them step by step. But I'm going to stick more to the formula determination. But before we do that, let's review the steps to determining a formula. So to determine a formula, I'll try to draw them small up here. Right? We said there's two formulas, the empirical formula, which is the lowest terms one, and then the molecular formula, which is the real deal. If you ran into this molecule out on the street, this is what it would actually look like. The empirical formula, remember, was lowest terms. And we often have to find that first. So how do we find the empirical formula? Remember, the steps were we had to get the mass in grams. All right? Now, if we were given percent composition, we assumed 100 grams and turned that directly into grams. Or the problem might give us grams right from the get-go, and we don't have to do this extra little step. Then, knowing that all formulas are based on amounts, we change the grams into moles. Because moles in chemistry is amounts. If a question asks you what amount of something is required, they want to know how many moles you need. And then what we did was we divided by the lowest mole number. All right, so we had the mole for each element. We looked at which one was the lowest number, and we divided them all by that. And then for the molecular formula, if you remember, what we did was we use the molar mass and we divided it by the empirical formula mass. And this is why we needed the empirical formula first. All right, so we often had to do this, or we got lucky and the question gave us the empirical formula, and then we got a number and we multiplied the empirical formula by that stuff. So there's our things there. I'll divide those two with a red line. Empirical formula, molecular formula. And sometimes you'd have to do this and this. So let's do a question from that worksheet, determining formulas in molar chemistry number 2. So the one I'm going to do first, well, let's do number 7. All right, we'll do number 7 first. And number 7 basically says, you've got a compound and it gives you the percent composition for each element. So for magnesium, the percent composition was 23.3%. And again, we take that and we turn it directly into grams. So 23.3% simply becomes grams. Also in that, sorry, this is number 7. All right, so number 7, magnesium. We also had sulfur, which was 30.7%. We just changed that into grams. And oxygen, which equals 46.0 grams. All right, so we just took our percent composition numbers, turned them right into grams. Now we have to change the grams into mole. And this is where the periodic table comes into play, because we're going to divide by the molar mass of each element, which is the, right? So for oxygen, it's 16, because oxygen on the periodic table is 16, is its atomic mass. It's also its molar mass, so it's 16 grams per mole. Sulfur is 3207, and magnesium is 2431. So that's why we need our periodic table for this step right here. So 24.31 grams per mole and 32.07 grams per mole. And then we divide those numbers out. So when we divide this, it becomes 0.96 moles, right? Because grams divided by grams is going to cancel. Grams divided by grams, no grams. All I'm left with is moles. This one also 0.96 moles. And this one is 2.875 moles. All right. So we changed each element using its own molar mass into moles. Now we have to divide by the lowest mole number. The lowest mole number is 0.96. Two of the three elements have that, so I'm going to divide by that. 0.96 moles. And then equals. I know these two will be 1, because it's any number divided by itself is 1. Moles divided by moles is going to cancel. And this one ends up being 3. So our empirical formula is Mg, it's 1, S is 1, and O is 3. So MgSO3. And that's all that one asked for, was the empirical formula, right? Number 8 was very much like that, I believe. It was very similar. So you'd follow the same steps for 8. Let's do number 9, very similar to this. Number 10, very similar to these steps, all right? So chemistry is like any sport or like a musical instrument. If you want to get better at it, you have to practice, right? There's a certain flow of thinking you have to, get into your mind. And so by practicing this, hopefully it becomes like you recognize the patterns in that of solving the problems, and you get through it quicker. Pause the video if you need to get this one down. I'll set up our next question. So pause the video right now, and I'll set up our next question. So one that involves number 11. Oh, what's going on here? All right, so number 11 off of that sheet. It tells us that the empirical formula, it already gives us it, the empirical formula for a compound is CH2. All right? And it tells us the molar mass of the compound. So the molar mass is equal to 42 grams per mole. And it wants to know what's the molecular formula, right? It wants to know what this is. So what information do we need? We need a molar mass, that was given in the problem, and we need the empirical formula mass, which I'm going to get from the empirical formula. I'll just take the mass of this. So I'm using this little formula down here. So molar mass divided by the empirical formula mass. I'm shortening it up here. You guys know what that stands for. So the molar mass given in the question was 42 grams per mole. The empirical formula mass I get from this. So I take this and I see C is 12.01. There's two H's, so that's 2 times 1.01. These are the values off of the periodic table. When I add that up, it becomes 14.03. So that's what I put here. And it's grams per mole. Grams per mole on top and on bottom, well, when I divide, they cancel out. So grams per mole divided by grams per mole is no grams per mole. There's no units with the answer. And when I divide that out, I will get 3. Now, if you get 2.99 or 3.01, we round that off. This is how many times larger the real thing is over the empirical lowest terms formula. So 3 times CH2 is equal to C3, because there's a little 1 there we don't see. And 2 times 3 is 6. So our molecular formula is C3H6. All right, easy enough? Okay. Pause the video if you got to get number 11 down into your notes, and pause it right now, and I'll start our next question. All right, number 12. Number 12 has 3 elements. It gives us the percent composition for each element. So we've got carbon, hydrogen, and oxygen. And we want the grams. They've given us percent composition, so we'll turn that directly into grams by assuming the 100 gram rule. So 38.7% becomes 38.7 grams, 9.75% becomes 9.75 grams, and 51.55% becomes 51.55 grams. Step 2, grams in the mole. So I'm going to divide by the molar mass of each element. These are the masses on that periodic table. So 12.01 for carbon, 1.01 for hydrogen, 16 for oxygen. You're probably starting to remember some of these by now. And it's grams per mole because it's a molar mass. And this one ends up being 3.22 moles, 9.65 moles for this one, and 3.22 moles for this one. That tells me that carbon and oxygen are in the same amount in that formula. Whatever their subscripts are, they're the same. Anyway, our lowest number here, divide by the lowest mole number, I've got 3.22, so it's 3.22. I divide all of them by that same number, so 3.22, 3.22, 3.22, and it's moles, moles, moles. These two obviously end up as 1, and this one is 3. And we can tell that moles divided by moles will cancel, just like grams divided by grams would have canceled out, right? Just left us with moles. So therefore, our empirical formula is CH3O. All right, so that's our empirical formula. I think this question is asking for our molecular formula, the real deal. So this is lowest terms, all right? So let's use this. Our molar mass divided by the empirical formula mass. Now the molar mass was given in the question, right? I said the molar mass is always going to be given to you. So the question said it was 62.07 grams per mole. And our molar mass, when I add up 1 carbon, 3 hydrogens, and 1 oxygen using the atomic masses of the periodic table, I get 31.04 grams per mole, right? So for CH3O, I take 12.01, 3 times 1.01, and 16. And I add those all up. And that's where I got this number right here. All right? Same as last video that we did problem solving. And these will cancel. Grams per mole divided by grams per mole is no grams per mole. And this is going to be 2. So that tells me that the real deal, I need the space, so I'm going to erase that. The real thing is going to be 2 times CH3O. So my molecular is going to be C2H6O2. And that's my molecular formula. All right? So those are pretty standard ones. Now let's do a couple that have that hitch to them, okay? So pause the video if you need to double check 12, or hopefully it went right, or you can check and see where maybe it went wrong. But pause the video right now. I'm going to set up our next question. Excuse me. All right, our next question. Now I'm going to do one of those ones that I said, this has a little hitch to it. There's something extra we have to do here. And those questions were 15, 16, 17, and 18. So I'll do number 15, and the same sort of thing happens with each of the questions, all right? So I'll do 15 and 16 with you, and then you try the same thing with 17 and 18 if you haven't done it already, all right? So we'll do number 15 here. Number 15, 3 elements, carbon, hydrogen, and oxygen. Go figure, very common elements in chemistry. And it gives us the percent compositions, which immediately we will turn into grams. So anytime you get percent composition for formula determination, we have to turn it into grams right away. So that's done. And now we are going to follow our steps. So we've got the grams. Now we're going to turn them into moles by dividing by the molar mass for each element on the periodic table. So using the atomic mass, and it will be grams per mole. And when we divide that out, I get 3.94 here. I get 10.49 here, and 2.63 here. And they're all moles because grams divided by grams will cancel. So these are all moles. And now I divide by the lowest mole number to get my empirical formula. And that's what this one's asking for. It's asking for empirical formula, that's it. So, and I know if I get the empirical formula, I could do this step pretty easily. It's in getting the empirical formula, these ones have a special little hitch. So my lowest mole number is this one. It's a 2.63, so I will divide by that. Divide it by 2.63 moles and divide by 2.63 moles. Whatever the lowest is, you divide all of them by it. Now I know this one's going to be 1 because I'm a math whiz. This one is 4, and this one is 1.5. You're double checking it on your calculator, and it's like, man, I haven't had that issue before. All right, 1.01 I just turned into 1. 2.01, I made that 2. Maybe this was 3.99, it's 4. But this is our problem. This is the extra little hitch that we have to be aware of. Excuse me. So 1.5, that's right in between. I can't just ignore that and make it 2. I can't ignore that and make it 1. I have to deal with this. This is telling me something about the empirical formula, right? And what it's telling me is that in my empirical formula, there are no 1s. And I'll show you how it tells me that in a second. So I'm going to take all this middle part out and we're going to rewrite this down below. So I'll do it in red because we're addressing our problem. So if I take the carbon ended up at 1.5. Hydrogen was nice, it played nicely and gave me 4, and oxygen was also nice and gave me a nice even number of 1. Then I've got this. So how do I get rid of this 1.5? Because I can't have 1.5 of a carbon atom in a formula. It doesn't make sense. That's what that's saying right now. The formula would be C1.5 H4O1. I can't have half of an atom. I either have a whole atom or I don't. So in this scenario, I have to get rid of this 0.5. To get rid of that and make it a nice even number, I multiply by 2. But of course, I have to do that with all 3 elements. So to get rid of the 1.5 right here, I multiply by 2. But I got to then do that for all of the elements. 1.5 times 2 is 3. 4 times 2 is 8. And 1 times 2 is 2. And so my empirical formula is C3H8O2. Sorry, it's a pretty bad looking C, but you get it. So this is my empirical formula. And there's no 1s in there, right? My lowest number is a 2, but I can't reduce it, right? The 2 and the 3 aren't going to reduce. 3 is a prime number. It's not going down, right, any further. So this is my final answer here. And the fact that there's no 1s in any of the subscripts is why we got this. That's what this is telling me. So if this had been 2.5 or 5.5 or whatever, it tells me I have to double. And then I get 3, a nice round number. All right? So pause this video right now. Get this down for number 15 if you didn't solve it, if you didn't figure it out on your own. If this threw you off, get it down now. I'll do the next problem. Going to do 2 more problems, one more that's on the sheet and one that is not. All right? So let's do number 16 off of the sheet. 16 has potassium, it has chromium, and oxygen. Excuse me. And again, it looks like it's given us percent composition. So I'm quickly going to convert those directly into grams. So all my percents become grams. Step number 1 over here. And 38.07 grams. So step number 1 is done. I got grams. I'm now going to do step number 2, which is converting into moles using the values on the periodic table. It's 39 grams per mole. Chromium is 52.00 grams per mole. And oxygen we know is, let's divide, sorry for the sloppiness, 16 grams per mole. Grams divided by grams, they'll cancel out. I'll be left with moles for every element here. Wow, this looks really bad. Okay, moles. And so I end up with 0.68 moles for that, 0.68 moles for that, and 2.34 moles for that. And last step, divide by the lowest mole number. That's my 0.68, so divide it by 0.68 moles, divide it by 0.68 moles, divide by 0.68 moles. Obviously, these first 2 will be 1, and this one ends up being 3.5. So again, I'm looking at that. I can't make this 3, and I can't make it 4 because that value is right in the middle. So this, again, is a problem. But as we just saw, it's not a very big problem, right? I'm going to deal with the problem down here. And so I'm going to just rewrite this. K is equal to 1, CR is equal to 1, and O is equal to 3.5. So this was our little issue right here, this 3.5. To get rid of the 0.5, this part of it is the key, this 0.5, I double it. But I can't just double the 1, I have to double all of the elements involved. So this becomes 2, that becomes 2, and this becomes 7. And again, my empirical formula is K2 CR2 O7. So you see that again, there's no 1s in there. And that's what this 0.5 usually means, is that there'll be no 1s. If I look at it right here, if that was just a 3, it would be K1 CR1 O3. But that 0.5 means there's no 1s. These became 2s because we had to double it. All right, so that's our answer for number 16. I'm now going to go off the grid, and I'm going to do a separate question that has a little bit of a different hitch to it, very similar to the work that we just did. All right, so this one you can write down as I do it with me, or as I do it with you, sorry. Pause the video if you need to, if you got to get this down, double check it. I'm going to erase it. All right. So the question is, a compound contains, I'm going to write it down so all the info will be there. This was not on your handout. This is my own question that I just made up. So a compound contains tin and phosphorus. A 25-gram sample has 18.55 grams of tin and 6.45 grams of phosphorus. What is the empirical formula? All right. Pause the video. Write this question down. So pause the video, write this question down, and now I'm going to go into the solution of it, right? That's the beauty of YouTube. Anyway, I've got two elements. If I kind of go through here and I, put the important stuff in here. I've got that much tin. I have this much phosphorus. I'm looking for this. All right. The 25 grams is not an important number. These two values here add up to the 25. It just says, hey, this compound, I've got 25 grams of it. These are the individual masses. And that's what I need, the mass of each formula, or of each element in the compound. So I've got my mass of tin, I've got my mass of phosphorus, so I'm good. And I'm looking for the empirical formula, so I got to start these steps right here. I got to do these. So first element is tin, and tin on the periodic table is Sn. The other element is phosphorus, that is P. Tin, 18.55 grams. Phosphorus, 6.45 grams. Now notice these two values don't add up to 100, and that's because they aren't a percent composition. These are the actual masses in this larger mass of the sample. It's still grams. We're given grams, so I have grams already. I don't have to do this. They gave me grams. I start with that. The rest of it is still the same. Now I divide by my molar mass off the periodic table for each element. Tin is 118.71 grams per mole. Phosphorus is 30, that's a bad zero. Get rid of that. 30.97 grams per mole. And that will equal grams divided by grams is no grams. I'll have my molar values. That's what I got to find is moles. So this one ends up being 0.156 moles. And this one is 0.208 moles. I look at that. I got to divide by my lowest mole number. That's this. So 0.156 moles. I divide by that. And I divide this by that same lowest mole number. This one ends up being 1, obviously. And this one is 1.33. And it just keeps going, 3333. So, again, if this was 1.01 or 1.02, I'd leave it as 1. But 0.33 is a lot. I can't just ignore that. And I can't use 0.33 in a formula. Right? I can't have a third of an atom. So, what do? This is my problem. So I'm going to reduce this down. I'm just going to write my values. Right? Sn was 1. P ended up being this. So, tin was nice and easy. It was 1. Phosphorus, not so nice and easy. This time it's a 0.33. Now, when it was a 0.5, I doubled it. It's a 0.33 now, so I'm going to triple it. All right? So, multiply both by 3. 1 times 3 is 3, and this is 4. 1.33 times 3 is 4. Nice and even. Therefore, my empirical formula is SN3P4. This looks like it might be tin 4 phosphide, right? Tin 4 phosphide. So again, there's no 1s in any of the subscripts. So this is the little hitch. And 15, 16, 17, 18 on the worksheet had that. This question had that. Where you ended up with a number that it wasn't 1.01 or 0.99. It was too big to ignore, this decimal. So pause the video right now if you're going to get this down. Here's our empirical formula, which is what we had to find. I'm going to go over how we can identify when to multiply by 3, when to multiply by 2. All right, you probably figured it out already. I'm going to write out a little thing here, okay? All right, so if you get a number when you're doing the formula determination, right? So in formula determination, if you get a number that is 0.5, so 1.5 or 3.5 or whatever it is, some number and it's 0.5, this is the key part of it, the 0.5. You are going to multiply by 2. If you get a number that ends in 0.33 or 0.67, you're going to multiply by 3 in both of those cases. All right? So, the last question I just did with you, one of our values is 1.33, and we multiplied by 3. All right? The reason for it is this. 0.5, that's a half. 1 over 2. So we multiplied by the 2. 0.33 is 1/3. So we multiplied by the 3. Or 0.67 is 2/3, and we still multiplied by the 3. So we're taking the bottom number that would have been, if this was a fraction, we take that bottom number and that's what we're multiplying by. And it gets rid of the decimal altogether. But we have to do it for each element in the formula. We can't just do it for the one that's a problem. You got to do it for everybody. Just like this step, divide by the lowest small number, we do that for everybody. We got to do this for everybody in that formula. And again, 1/3, we take that 3 that's at the bottom, multiply by that. 2/3 is what 0.67 is. We multiply it by that bottom number in the fraction. All right? So remember this, write this down into your notes. Use this information if you messed up on 15, 16, 17, or 18, or you haven't gotten there yet, remember this stuff for when you do get there. All right, that's it for now. Hopefully everything went well. If there are any questions, please ask. Don't sit there and not know. You got to ask me. You got to let me know. I can help you out. Anyway, hope you enjoyed. Hope things are crystal clear. And if you have any questions, comments, or concerns, as always, comment below the video in the comment section of this YouTube station, or reach out to me through Edsby. Please do. It's never a problem. All right, I'll talk to you soon. Bye-bye.